In Unit 6, we're going to talk about similarity. We're going to cover several standards in our state standards here. And in day 1, we'll take a look at dilation, scale factor, and similarity. So for our activity today, it's called How Tall is LeBron James? LeBron James is one of the most iconic American professional basketball players. He currently plays for the LA Lakers, has won 4 NBA championships, and is third all-time in points scored. Posters of him abound, but can a picture really do him justice? Number 1, look at the photo of LeBron. What do you notice? What do you wonder? Number 2, based on the photo, estimate his true height. What's a too low estimate? What's a too high estimate? Number 3, with your ruler and protractor, measure the following on the photo in centimeters. So the first would be his height. So that would be how tall he is from his head to his toes. Next would be the length of the Lakers script on the jersey. Also measure the size of his head vertically. His leg length. His torso length, his shoulder to his hip, and this angle made by his right elbow. Now, in case you don't have a protractor and you're at home, we'll put that angle here, and hopefully you have a ruler. So the angle made by his right elbow is 80 degrees. And then if you want to check your answers for his height, I got about 12.5 centimeters. The length of this Lakers script on his jersey, I got about 1.5 centimeters. The length of his head vertically, I got about 1.5 centimeters. His leg length, about 7.5 centimeters. And his torso length, about 3.5 centimeters. Now let's think about real life LeBron when this picture was taken. His true height is 6 feet 9 inches. And if we convert that to meters, it's 2.03 meters, and that would be 203 centimeters. It says, how many times bigger is LeBron in real life than in his photo? So if we take a look at his height, in the photo it's 12.5, and then here's his height in real life. So we're looking at real life divided by his photo to see how many times bigger he is. And we'll take 203 divided by 12.5. So in taking a look at this photo, in real life he's 16.24 times bigger. So using that, it says, can you find out his other real-life measurements? For example, the length of the Lakers script. So if you multiply 1.5 times 16.24, we'll get about 24.36 centimeters. For example, the size of his head, we can multiply 1.5 times 16. Okay, so it's the same as the length of the script of the Lakers logo. So there's the length of his head, and you can do his leg length, the torso length, and the angle made by his right elbow as well. Well, actually, will the angle change? And the angle won't change, even though all the sizes will change. 6, how do the measurements of the photo compare to his real-life measurements? So how do you answer that? And class will talk about that. And then it does talk about what is his real-life torso to his leg ratio. And then what do you notice? So if we take a look at his real life torso to leg ratio versus the ratio that we have in centimeters. So here's his real life. Well, actually, let's do what we had measured here first. So his real life torso to leg ratio. So torso is 3.5 to his leg ratio, 7.5. Okay, torso to leg. Now let's calculate that. I'm going to go ahead and divide that out. It's about, I should put approximately, 0.47. And then in real life, and I didn't write these down, but I have them here, His torso, we should have gotten about 56.84 over his leg ratio. And if you notice, you get the same thing when you divide out the ratios. So then in class, I'm going to hand out okay, so I'll hand you these resized photos. I'll show you what they look like. And it says, Miss Bajan is a huge LeBron fan, so she decides to resize this photo to fit it on her phone, case, water bottle, notebook, and anything else she might find. How might she go about doing this? How would I resize the photo? So think about ways that photos are resized. Number 9, look at the set of resized photos your teacher will hand out. So I'm going to pop these up here. Okay, so here's a bunch of resized photos. What images do you think portray LeBron accurately? Can you explain? Can you choose one image that you thought was an accurate representation and prove that's accurate? Then choose one image you didn't think was an accurate representation and prove that it's not accurate. So think about how you could show something as an accurate representation versus how you could show something as not an accurate representation. In class, I'll hand these out and we'll have rulers. We'll be able to measure. So then it says, to make a classroom poster, Ms. Bajan decides to take the original photo and scale it up 350%. Can you now find the following measurements on her poster? So one thing to help with that, if it's scaled up 350%, think about that scale factor. It'd be 3.5 times bigger for the scale factor. How would you use that to find the new measurements on the poster? And then we'll go over in class quick notes once we do the investigation. And so we'll write those up. So our quick notes, similar figures. They have the same shape, but a different size. All sides are enlarged or reduced by the scale factor. A scale factor you can calculate by figuring out your new ratio or your new measurement to the original. And we'll talk about that in subsequent days. Ratios of sides stay the same. Angles also stay the same. So ratios are congruent and angles stay congruent. Okay, so here's your daily practice 3 problems. So look through these, see if you can use what you've learned today about, like, what is a similar figure? How did we look at LeBron James and figure out how to find these new measurements using a scale factor to solve 1, 2, and 3?